We called this as H-bridge arrangement, which would do at least half the job. To make proper AC, you'd need a switching H-bridge arrangement that allowed you to reverse the current completely and do it about 50 to 60 times every second. Visualize yourself swapping your switches back and forth over 3,000 times a minute. That's some neat fingerwork you'd need. That is why we use the fastest switches in the world, transistors. We can use transistors, more specifically, insulated gate bipolar transistors or IGBTs. The most common IGBT switching frequency ranges from 20 to 50 kHz. An IGBT is a 3-terminal power semiconductor device primarily used as an electronic switch. IGBT can be switched on and off by activating and deactivating the gate. If we make the gate more positive by applying voltage across the gate, current can flow from the collector to emitter. So the IGBT in its on state. If we make the gate negative or zero, the current flow stops and IGBT will remain in off state. We can use IGBTs as switches. At its simplest, an inverter consists of what is known as a H-bridge arrangement. This circuit illustrates the implementation of a single-phase H-bridge circuit using 4 IGBTs. The operation of the H-bridge is straightforward. By closing A and B, and opening C and D at the same time, current starts to flow through the bulb from left to right. By opening A and B and closing C and D at the same time, current starts to flow through the bulb from right to left. Likewise, by turning on and off the IGBT switch pairs reverses the current direction. That means alternating current is generated. To work these IGBTs correctly, accurate control signals must be provided to A, B, C, and D. These control signals are generated by a separate circuit which can control the frequency of the output AC signal. As an example, we can use a cheap Arduino board to supply these controlling signals. Even though we converted the DC to AC square wave, it's not at all like the AC sine wave supplied to our homes, which varies much more smoothly. To avoid damaging the IGBTs at short circuits, when changing polarity it is necessary to turn off one set of IGBT before turning on the next. During the transition, all the IGBTs must go off at one point. We normally use a diode with an IGBT to provide a necessary path for inductive current in